Can you hear me? I can't hear you.
Yes, I can. Hello? Hello?
Can you hear me?
Yes, I can.
I'm not hearing them though.
Yes. That's better.
Can you hear me? Jeffrey, I can see you. Can you?
Yes, yes, I can.
All right, are you finished with the activity on the board?
I just came in.
Okay, Sabina, are you there? Zana? All right, so I have an activity on the board. Can you attend it for me, please?
Yes, I'm there. I've already attempted it.
So you're finished. All right, let's give the others some time to think about it.
I'm finished.
Still working? All right. So let's give the others some more time, please. Sabina, are you finished?
I think she stepped out.
I'm seeing Sabina here. Sabina, can you hear me?
She said her internet cut off. That's why it's giving trouble.
Okay, okay, okay. Oh, okay. Michelle? Yes. No success? Really? Take up work with the so when she gets there. That's incredible activity. All right, so we're still giving the others who are working some more time, okay? It's okay, it's fine. Huh? I'm just feeling sick today. Because I wouldn't give it to me. Oh, you wouldn't? I thought you'd have it. Few more minutes. Jeffrey, Davy, what are you doing online? Jeffrey, did you get all the diagonals to add up?
Yes, I did.
Diana, are you finished?
Yes.
Davy, are you
Yeah.
finished? I'm not hearing you, Davy. I'm not hearing Davy.
No, that's all the activity.
Oh, you sound very low, so you have to turn up your microphone or something.
Let me see if I can find it.
Zana? Zana, are you finished? Sabina?
Yeah, I'm finished.
So more of the students are still working, so we're giving them at 2:30. I have to stop you guys. So give us some more time.
Miss McCarthy, a question.
Yes, Jennifer?
Hi. Our group, the solution group, we were wondering if you wanted us on Thursday to go up to the center. We asked permission. They said if you want us to, we can go ahead.
That would be nice. So you guys can actually teach the persons there.
Yes, so we can be together and use the group as a class instead.
Oh, very good. That's very good. That would be nice.
Okay, thank you.
So I think so. So I think on Thursday we'll start at 3 because we're having some room challenge. So I think there'll be a class in this room until 2:30. So let me put it at 3 for this class on Thursday. All right.
Okay, no problem.
All right. So if we're not finished teaching by 7, we can go finish Friday morning and then finish because the class ends on Friday, right? I will.
Yeah.
Friday afternoon, yes.
Yes. This course ends on Friday. So summer 2 start July 20, right? 20th?
The 20th.
Okay, so you'll get some break to kind of unwind a bit to come back. All right. And your
When,
assignments. Mm-hmm.
yeah, I think, well, I guess I'll be 4 o'clock first because it's an hour behind. So you said 3 o'clock.
Yes, because we have a class here until 2:30. So I'm taking it that by the time the lecture is done and then wrap up, it's about, near 3. So let me just put it to 3 just to ensure that we're safe, okay?
No, I'm saying it will not be 3 o'clock here. I think it will be 4 o'clock here.
It will be 4 in our time.
So you're talking about an hour later.
And oh, yes, so but I'll try to wrap up by 7 still. But it's
Okay, no problem.
your time, 8 o'clock, because I understand that you guys probably have things planned. But we'll finish up on Friday just in case, all right? All right, so I have to move on now. So let's see what you're coming up with. Who is finished? Who wants to give me what you're coming up with?
I can.
Yes, go ahead.
Well, I started with 1 in that, yes, the block that you have there. We're going horizontally, 5 and 9. Not
Horizontally.
yes, not across. At the top, the same row. Then
I don't know why. I'm thinking diagonally. I don't know. All right.
Then the vertical row from 1, 6 and 8.
Mm-hmm.
So I use these as my base and the others I filled in. After 6, the column with 6, it will be, the row is 6, 6, 7 and 2. And the next one, it will be 8, 3 and 4. 3 and 4.
All right, so let's, but the diagonals are correct? No, because I got that, but no, I got something similar, but one of my diagonals.
Oh.
All right, let's see if we have anything different.
Can I try?
Who wants to go next? Jeffrey, you can go.
The first row I have 2, 7 and 6. Then 9, 5 and 1. And 4, 3 and 8.
Can we check that quickly? All right.
It's correct.
All right. Any other solution?
I have another one.
It's the same numbers, just arranged differently.
Okay.
My first row is 8, 1, 6.
Mm-hmm.
My second row is 3, 5, 7.
Mm-hmm.
And the third row is 4, 9, 2.
Okay, good. Any other?
I have another one.
Okay, go.
The first row is 8, 3, 4. The second is 1, 5, 9. And the third is 6, 7, 2.
6, 7.
2.
Okay. All right. Any other solution? All right, very good. I'm trying to see if I can give you another hour to work on the lesson plan and then we'll talk about it again on Thursday. I'm trying to see. So I'll try to see if I can find another hour in this class with another hour to give you to work on your lesson plan, and then we continue to discuss. So you work on it for half an hour and then we discuss for half an hour just to ensure that we're all on the same page, okay? Remember this is a when again? Thursday. So you're teaching your plans on Thursday. So by now I'm assuming that you all should be somewhere fair enough, you know what I mean? So we can start to have a conversation. So I'm going to give you something to work on. You can work on it in groups if you wish. You can speak on your WhatsApp group. So if you wish, you can talk on your WhatsApp to decide what to do. But basically, most of it is just a recap of what we've been doing so far. I'll read that one for you. So let me explain what is expected. So we're going to work on this stuff. I'll give you talks on hour so we can discuss, so you can discuss afterwards. What you're going to do is, so this is your topic, these are the topics or subtopics. So for example, the first one I have there is area. What is the concept of area? You're gonna write down that concept of area. Then you're going to think, now, if I need to teach this concept of area, how would I go about it? What are the steps that I would take? So you're going to list those steps. Including those steps are your manipulative and how you'd use the manipulative. Is that clear? And then the algorithm. What do I mean by the algorithm? All right, so the step-by-step in solving a question, the step-by-step process in solving the problem. So, for parameter, first you're going to write down what do you think is the concept of parameter, the idea behind parameter. Then you're going to write down how you'd go about helping students to understand this concept. So basically, you're going to write the manipulative you would use and how you'd use it to develop the concept. All right? Then you move on to volume. What's the concept of volume? And how would you help students to understand this concept? Percentage. What's the concept there? And how would you help students to understand that concept? Then you move into division, which is a very simple concept there. But, you know, how would you get students there? And then length conversion. So let's say, basically, if you're converting from kilometer to meter, something like that, how would you get, because I think that's that area, problem area for most students, right? So how would you get them to understand that, all right? So you can work on it individually, if you wish is your option. Or you can talk on WhatsApp, for those of you who are overseas and online. You can talk on WhatsApp and work through this. I'll give you an hour to work on this. If you need some more time, I'll give you a top 15 more minutes. And then we'll stop and discuss. All right?
Hi, Miss. Just now.
Yes.
Miss McCarthy.
Yes, Zana?
We are looking at the topics you highlighted there, right?
Uh-huh.
Each one or one we are doing? Each one of them?
You're doing all of them.
But but the funny thing is that I can barely see you.
Okay, so
What you have on the board, that's why.
Oh, I understand. So you're doing area, so you can write it. You're doing perimeter. You're doing volume.
Yes.
Percentage. division, percentage,
Division,
and length conversion. Say convert.
length conversion.
So let's say convert from centimeters to meter or from millimeters.
Right.
Yeah.
What's the middle heading you have?
And so the middle heading, so the first heading here is a topic / subtopic. And the here I have the concept, then I have slash, list the steps you would use to get students to understand the concept. They must list the concept, and then you need to you must state what the concept is, and then you're going to highlight, just list, write down how you would get students to understand the concept, and they should include a manipulative, all right?
Right. And the last one is the algorithm, the steps.
That's it. So let's say I'm doing perimeter. How would you, what's the algorithm there? Let's you show the student.
Okay, thanks.
Davey, you look a bit confused. Are you okay? I'm not hearing the same mouse moving, but I can't hear you. Could you turn up your microphone, please? Yes. I don't think it's our problem. I don't think it's Mona's problem because I can hear the others. Their problem. I'm hearing it just slightly, but not just slightly. I don't think it's a Mona problem because I'm hearing the students, the other students. So I'm hearing same person from St. Lucia. I'm just not hearing you.
I don't know. I probably need to change the microphone.
Oh, it's a microphone.
Yeah.
Oh, it's very low.
I guess I'll have to go and sort out the technicalities.
Okay, I hearing you now though, but all right. I think I'm gonna work on that right now. Yes, Davey, are you still saying something?
No. It's just that I have a lot of noise in my background. So I have to focus to listen.
All right. So do you understand what you need to do?
Yeah, I guess.
You guess?
Yeah, man. I'm there.
All right. So
Hi.
yes.
Can I disconnect and reconnect in an hour? An hour you said, right?
Well, yes, I was hoping that you guys would have taken over, but let's see. Okay, fine, no problem.
Okay, I'll come back in like 45 minutes. That's cool because I have some internet problems.
All right, no problem. That's fine.
Okay.
So later on, I want us to look at the diagram pieces and just have it move the set of where you are. Just how you're trying to be something. Turn it on. You can do them. See, you can have our and like when I listen to them, like because what happened because you guys had they had different pieces and then
or you have different pieces that you must put together to make a square?
Yeah.
I wouldn't like that.
You're like, that's what like the next time. It's a good thing we can go in advance. I think it is here. Okay, I want you guys to be very creative now. Yeah, maybe one thing will take on the entire page. I want you to be very creative, guys. Should I put media on this? Someone put media? That's fine. That's fine. I'll do this for a while. You guys working together? Together? I'll tell you, the steps you would take to get students to understand. The concept is, and then how you would do it. Yeah, okay, we'll take a resolution. Davy? Not hearing you.
I'm with you now. Can you hear me now?
I'm hearing you perfectly.
Oh, good.
Do you understand what to do? Or you miss your friends that you in Mona here?
I miss you. Come on.
You need a friend. You can talk to them.
Aren't you a friend?
No.
This is it.
So you can talk to to them on WhatsApp. You know, you're not on the WhatsApp group.
Yes, I am.
Oh, so you can talk to them on the WhatsApp group, so you guys can work together if you want, if that's what you want.
Okay. What I missed that. I'm trying to read the second column.
Okay, it is. So for the second column, you're going to have the concept. So you're going to write what do you think the concept of error is, and then, like, for example, so you're going to write a concept and how you would go about getting students to understand that concept. So you have to know the concept for yourself first. You have to write out what that is, and then you would just outline the steps that you'll take to develop that, to help students to develop the concept. Is it clear?
Yes, I am.
All right, good.
Okay.
Square unit, same as it does. That's the whole idea. They want to come over here. I'm actually so safe. What are some of the things you're going to do? What about a geoboard, geocade, and a have? So I'm giving you ideas. Think about graph sheets. Think about quick papers. I'm giving you ideas. Any ideas coming in? And in a room. Yeah, but I'm giving you ideas. Once I have ideas, we'll talk about it.
You should do a parameter first.
But you never say era, was it? Just say era. Just say anything. The irregular page, the height of the era. It was a parameter of what? So maybe you want to start the context. And you're just running it in a shape. Just well, yes, and then because yeah, you're gonna have some that are off, so you can start to estimate or you can put piece up there. Because you could do it with the drawing computation, because you want to tell them here is not enough. You could give them several different things and say, now what do you think? You know, they should be able to tell you. They should be able to tell you from that to this what. Or any recognition or something, anything that that's estimate. That's all right. Some of it's more like when we're accurate area. More estimate because you're hand. You need more like no, that's why you can. No, the one where you're done. Take up access. How would you design, draw a shape where the air is free? Take a couple of things. So one is that say, all right, I will this. Take it to make a thing, and then make it. I think that's it. This is 1, 2, 3, 4, 5. So they could draw anything. So you just write it all. I'm going to draw any amount of that. What about one to the air is 5? And then amount, you know what kind of reduce the bar. So these are the grades of the 8 and 9. No, school. No, this was 4 is because I So what you know, it's the big box, then the box in closing, that's 1 liter. So it just all comes together. It's and show that it's very time consuming. Very much. It's a good thing to do.
Each of them, right, the first three, you don't look at the concept of the unit. Just the concept.
So if you look at area as a concept, so it's general across the board, all the things different area. If you look at the volume, there's an idea of the surround volume, so you don't have to look at it in terms of volume of not just volume idea, because it could be like a first class. We're not looking at the volume of a cube or cube, that could come into it, but the main thing is what is it? how do you get yes? So it's a building the concept. Building. So it could be people want to continue as a Cuba is develop the concept, but you don't really have to. So it's the idea. So if you're looking at percentage, what's the idea behind percent? How would you get that? You get that idea.
But like for area where we're telling them about square units, we have to tell them like what is a square unit? What does it mean square unit?
But you could do that, you could tell them what's that. If they're counting, because Dr. said it's a square unit, why do you think they're square units? So exactly what's sitting there. I think that one thing that we want to run away from is telling students everything. We want to ask them, because sometimes they don't know. We want to ask them everything, because they all know about squares from primary school, from different, most of them know the square. So because it's a square, and we call it a unit because it's not, we can say it's not a standardized measurement, depending on how we use it. That's why it's called a square unit, because not all the standardized things. So we can say centimeters square because it doesn't have to be a centimeter. We don't want to say a millimeter. So we call it square unit because we don't know the exact what unit really. It can be millimeter square, it can be centimeter square, it can be, meter squares, whatever. But at the end of the day, there are squares that we use over the surface. And you can even discuss that there are sometimes when, depending on the surface, it's a large surface problem we want to centimeter squares. Don't it? Right. Because it is too tiny. So you can even discuss it and think about that. If you have a small space, you can say, all right, let me use a centimeter square, or even a millimeter square, because you're even tinier. But if you're doing a room, for example, from the times room, for example, would you want new centimeter square? You see what I mean? They can start discussing it, things like that. What's the meaning of it? What do you want it to be? Like, no. No, I didn't express this right. You know how we're lots of people went up for so yeah. So I'm saying that a little bit more than just saying that it's 100. I mean, even if it's really, what are you saying to them? What does this mean? What does this mean? Then when you say equal part 100, what is that saying? What reduction can you from even that understand? The underbar numbers are not because if you say it's equal to 100, that's a concept here because all of these things are connected. What is it connected to? Right. Is that really what I want to hear? Let's, for example, let's talk about ear to ear is a space. The idea is that ear is a bit more than the space to cover. If you're not talking about the word square and something is wrong, that's really not, you know what I mean? And if you're talking about fraction, I would just say whatever. We're not talking about what we mentioned equal. There's some core words that we need to pull out when we're talking about different concepts. So fraction, we cannot describe what we're talking about equal parts. Because if I have a ball and a brain from a tree, there's no fraction of a ball and it's the piece of the ball. So there's some core words that we must. So we must be precise about. I don't care what you find really, but the core words. So you can never bring it up and know equal parts, something is wrong. You can never hear that squares. Something is wrong. You're not balling that about cubes, something is wrong. So that's what I'm really key. So talk about percentage. I'm saying that because it is also a connected tool of the math idea and what is that idea. And I left that. But the thing is, you're saying equal parts. But that's how no one should tell people that you just mentioned it. Think about it. If you're saying equal parts, there are 100 events equal parts. What concept is coming out here? Think about it. Fraction. So give me a definition of percentage. These are one. With what? No, a fraction. Exactly. That's it. So you're saying the right thing, but how else can you say for students to understand? You might understand. So if you say a half, so that is right. If you say a half of a fine percent of a half, really is an equivalent fraction. You're thinking for a half, but it's not it's a little bit. And you say half 100, huh? It could be half 100. Yes, that's right. And 50. So if you have 100, so I mean, if you activities, right? If you have your 100 grades, and activities by a half, what percentage is that? So 70 shade of half of it. What is that? 50. That's 50% shade. If you say shade 1/3 of it, or whatever, or quarter of it, then you have 100. So a quarter of that 100 is really 25%. So you get the point of it. So, but also, if you come into your fraction idea, so that's one way to look at it, but also look at a fraction. If I have one quarter, and I understand that percentage is really a fraction of zero, it is 100. If I want to find that one as a percentage, all I need to do is figure out an equivalent fraction for quarter, really is 100. Yeah. So that's another. So just we really not bring not trying to shut them down, it's just a part of this or whatever. But to see the different, how they're related to the different ways they can be. And you're next to the coming there on stage. This is what they're talking about. No, I look at every day, even up to season. Six, area, and I'm saying that as a friend, another point I'm making is how many of these students and I've seen this as a volume of idea. So these are the things that they don't know how to do it. So that's it. Just like our common idea things that are very important. Yes, I mentioned it today. That's really not go direct, but the things that yes, you could have it. It's time to get this. I think the program for 10 year teaching. That's no problem. I'm 10 years teaching. 5 years as a teacher.
I'm just very intensive today. I was on to do. Something to do with just like it's coming to my head. I'm talking all over the place. Some ways of getting stuff. That should be easy. I think that would do. I think so. I think it would sound like I'm going to play the piece of subtraction. And then there's too many lines. So if you should say because there's too many lines. So if I have strength, and I said strength, and I'm dividing that sentence. That's not 200 saying, but that's not 63. That's 6,000, 6,000. So that's a lie. So if you're too many rules for misconception. Yes, there's too many rules, and that's what I know. Makes fun of numbers. Just say, so for the different algorithms, we want to push on like that. So if you repeat subtract, you take more money. No, because you're doing. I know. No. Because everybody knows when like 17 or 100. So if I was like 29, 19, that is 220, 210. So I can take that big one. Yes, I'm taking on. Yes, it's a number of words that says more good. Then I hope to, especially by small ones,
It's good. The participants will say,
And then if it goes, should it get bigger? Is it going to get bigger or smaller? Talk about that. Don't tell them because in the natural, so they should decide.
You should just say that for comment.
Yeah, that's what I started. Oh, I thought you were saying, so don't you?
Yeah.
Always have that idea. Like they're doing from me, that's the same way that they want to divide. So I'm saying, like, look at this big thing, you have one of these.
So it should be anything bigger or small. That's what we're talking about.
Yeah.
Bigger, they get them to change. They get bigger or smaller. Remember, it's small. Say it's gonna get bigger. What should we do to get it bigger? You know, you're gonna get much more back. And it's what it's say if it is 10 of this that makes space. And then most back and will come 10 times as large. You know? It's the values. So it's the idea you want to bring up one of that. I know that.
Yeah.
Or if
It's very exactly.
you know, that's not. And I was just doing something else here in the conversation. So that's another one. I'm going to build this out. Finish. Still working? All right, so need some more time. All right, who else needs some more time? Jeffrey, you're finished?
Yes, I am.
So I still have the students from you. We're still working. Need some more time? All right, so I'll give you another 10-minute stops. Diana, are you still working? Anya, are you there?
Yes, I'm here.
Still working?
Well, we could start with you.
So some students need a little bit more time, so we'll give you another 10 minutes or so.
Okay.
Zana is there. Anya?
I was the one there.
Anya?
Anya was speaking a while ago. Zana here now.
Zana, sorry, my bad. Are you finished?
Yes.
Are you finished working?
Yeah, I'm almost there. I'm actually almost done. So when you're ready, you could go ahead.
10 minutes. Diana, are you there? Just a little 10 minutes to wrap up. Diana, are you there?
Oh, yes, I'm here.
Are you finished working?
We can start, I don't think we could ever really finish.
All right, so I'm giving the others 10 minutes to wrap up. Some persons are still working. So
Okay.
Both are still working. So give it another 10 minutes, then we start.
Okay. All right.
Miss McCarthy?
Yes, ma'am.
Sabina said that her internet is giving trouble. It keeps connecting and disconnecting. However, she got the work, so she's working on it, but she's speaking to me via WhatsApp.
Who is that?
So whenever she gets Sabina.
Okay, no problem. I understand.
Okay.
All right, no problem.
You should say that. I see that the stream I started, especially. Oh, okay, okay. So, okay,
Is it working? All right, let's talk about tired, Ricardo. All right, since you're all tired now, all right, so what I'm gonna do, I'm gonna discuss the first two, and then I'll give you a break, half an hour break. So those of you who are still working can continue to work in that break time. And then we will come back and finish this, do some things with our tangram pieces, and I hope that we'll get some time to do the lesson planning. So let's see how that will work. Let's see how that will work. But we definitely need to do our tangram pieces. On Friday, which is the last class, I want you to look at some virtual manipulatives because sometimes we don't have the actual thing in class, but we can go online and explore with some virtual ones, okay? So I think I'll say over and then y'all have been I'm joking. Alright, so let's talk about the first two before I send you off for a break. Alright, who wants to go first? Who is burning up and want to share? Tasha? Look all excited.
Hi. No. I just walked in. I just came in.
Alright, not you?
I'm lost.
Who is that?
I'm lost.
You're?
I said I just came in.
You just got here. Okay, no problem.
Yeah. Sorry about the lateness.
All right, I do understand. All right, Jeffrey, since you're finished and bursting with excitement, let's hear you.
Okay, I can try for area.
Okay. 1 second, Jeffrey. Is Curly in here today?
I haven't seen her. I was just asking. Oh, she's there.
Carlene?
Yes, I just arrived.
Okay, all right. Carlene?
I'm not sure what is happening yet. Yes, I'm hearing you. I just got in. I'm not sure what is happening yet. I just got in.
All right, no problem.
Sorry about that.
That's fine.
Okay.
So Sabina's back with us, right? Good.
Yes, I'm back. Hopefully that'll help.
All right. So Jeffrey, you're going first. And then, since you're finished so early, you got finished so early, you can go. And so which one are you looking at, area?
Yes, I'll look at area.
What's the concept? What's the concept first?
Okay, first I defined area as the number of square units found in a flat object.
Okay, yes.
Are you hearing me?
So you said flat object. Do you want to change that to two-dimensional object?
Oh yes, that's what I was wondering if I should use that or just use a flat object so that they could understand it better. But which one you think?
All right, so let me tell you why I say that now, because that's kind of debatable in terms of, like in my paper, even though we use it as a plain shape, really, a sheet of paper, it really is a 3D shape. You know how we have this debate going on now, because once you have height, length, and thickness, and it's 3D, and in our physical world, it can actually be two-dimensional. So that's the reason why I'm saying, let's say two-dimensional, even though we might use physical things still, but we want to use the word two-dimensional.
Okay.
Yeah.
So I can put I can take out in a flat object and just put in an object and bracket two-dimensional.
Okay, good.
Okay. For the steps, I started with a question where I would ask them to find the area of, and I drew a circle with a radius of 12 centimeters. That's the first question. And then the second one, find the area of.
Yeah, but how would they, because the all right, sir. So this is what I'm not understanding.
You want me to actually teach them how to find the area in terms of physically or using the formula? That's what I was thinking.
Okay, so what I had in mind, I don't know if I was clear, so let me try to say it if I can think of another way. So we understand the concept is the how many square units that can cover a surface or something, all right, fine, or two-dimensional object. So that's the idea, that's the concept. Now, if I know as a teacher now, I understand what the concept is. I now need to develop that concept, get the students to understand that concept. What are some of the steps? What are some of the things I would do with my students for them to get the same understanding of area? Are you clear? All right, so
yes, I am.
You want to tell me no? Because I wasn't getting...
I was thinking, get them to cut out 1 cm square units from measure 1 cm little squares from paper and try to cover. Are you listening?
I get to exactly what you said. Get it to cut out sheet of paper. Yes, I'm listening. Trust me.
And have them cover the circle with the 1 cm square units and check how many of them would cover that particular circle of with a radius of 12 cm.
So
would that work?
Okay, so so let's think it through together first. So for them to do the 1 centimeter, this would have to be drawn to scale. Are you saying that? Are you getting what the point of
using the yes.
So
and that would be you. What if, as the teacher, you brought in the manipulatives ready? So you bring in the circle with a radius of 12 centimeters, and then you brought in this little 1 centimeter square units, and you give it to them and have them measure. Would that be easier?
I'm not saying that they could do that, but I don't know if that's where I would want to start. That's the thing I'm thinking through. Nothing is wrong with having, because I could even have them draw it on a graph sheet or on a grid and then count. It's not a problem.
Yeah.
But provided that they need that scale to be able to construct that circle there. I don't know if that's where I would want to start, depending on the age group. So, but nothing is wrong with it, but it would, the thing is that if it's a grade 8, then probably you could use that. Grade 7, don't even construct circles yet. So depending on the grade level. So nothing is wrong with doing that activity per se, but you want to look at the grade level and to teach it and what they can do.
I was looking. Sorry, I was looking at grade 9. That's why.
Okay, I see. Okay, no problem. That's good.
And then you can go ahead, Sabina.
No, that's okay. Go ahead.
And I was thinking for my algorithm, I would give them the actual formula to calculate area, and I would show them how to use the formula as well to prove what we got in terms of when we were measuring our number of 1 centimeter square units on the circle.
But there's a missing piece now. Can you all pick up the missing piece? All right, so she's saying that she would have them draw this circle on the grid and then count it, which would basically give an estimation, but not the actual area because of the shape. And you have to assume that pieces will be put together.
Yeah.
Yeah, so that's fine. That's perfectly fine. I don't have a problem with that activity. But the point where I'm saying that there's a missing piece, Jeffer, is because if the students are going to lead from that to the formula, then there's no real connection. I don't even see there's a gap there. So they now would probably need to cut the circle and turn it, remember that activity, into a rectangle, derive the formula, and then they can use the formula. We never ever want to just give them the formula. We want them to we want them to realize that this formula didn't drop out of the sky. So I would do the activity, then cut the circle, the circles into different sectors, form a rectangle there, derive the formula, and then have them apply it, and probably make a connection to see, you know, what do you notice is there?
I understand.
All right, good. All right, David, you want to go next? Oh, Sabina, you were saying something. You want to go next?
No, well, yeah, before I get disconnected. Are you hearing me?
Yes.
What I was saying is that I actually, I did some, since you was on that topic area, I just wanted to see what I did in that topic. Are you still interested in hearing?
I'm definitely hearing. I want to hear what you have to say.
Okay, so when I did area, well, I did not do a circle, so I was thinking of area of plain figures, like rectangles and squares. And
tell me what concept do you have written down there?
Area of plain figures.
Yes, so what's the concept of area without it being attached to any?
Oh, okay. Okay. The area is the number of square units inside a figure is called the area.
All right.
That's the concept.
All right.
I would use like I forget the name of the diagram you give us to use. The geoboard.
Okay.
And a rule. Well, let them use a geoboard, the 100 dots and a ruler most likely, and ask them to use that to calculate, like to draw different shapes. So go, like 4 units down, 3 units across, and draw this figure. It will be a rectangle. And then I'll ask them to draw the number of small squares inside of it and count how many. And that would be the area.
Very good. I think the Mona students were thinking something like that. Very good. I heard them.
And then the algorithm to transfer from this to the formula. I'm still using the 3 squares by 4, 3 by 4 horizontal vertical. I would ask them to, we will do more than one example. We'll also do for different rectangles, squares. And then I would ask them to, let's say the one for 3 units by 4 units, ask them to find a relation, because the answer would be 12 squares. Okay. I'd ask them to find a relationship between the 3 across and the 4 down and the answer that they get, which is 12. And then probably like a few other examples. And then they would realize that to get the area, you'd have to multiply the horizontal distance by the vertical distance, by the vertical number of squares, basically.
Well,
so it would be,
sorry, I didn't know you were finished.
Okay, go ahead.
No,
yeah, I'm finished.
Very good. Very good job. That's really impressive. Good job.
Okay.
All right. So even though you kind of link it to just the concept, you define the concept, then you link it to the area of rectangle. It's a very good method of getting students to understand the idea of area. All right. Who wants to go next? Very, very good, Sabina. Very good. Who wants to go next?
Next one is what? Perimeter?
We're moving from perimeter. You don't want to hear any other person.
Area?
I want to hear other.
Oh, you want area? You wanted me to do area as well?
All right, let's go.
Okay, what I have for area is the area of any shape is the amount of stuff or whatever that you would use to cover it.
Stuff?
It's the amount of square, it's what you use to cover it. It's not this, there's a plane that you would use to cover that particular shape, because it doesn't have to be a plane shape or a standard geometric shape.
Okay.
So it's the amount, yes.
I think I missed something. It doesn't have to be a plane shape. What do you mean by that?
Okay, it doesn't have to be, let's say, a square, a circle, or one of those shapes.
Okay, I get you.
So if it's, you know, if it's an irregular shape,
Actually,
you
do you know
can.
what an irregular shape is? What's an irregular shape? Who wants to tell me?
It's you can't define it. Let's say it had, if you look at
Compound shape you're talking about, a mixture.
not only a compound shape. I've moved away from a compound shape. Let's say it's you break something and the edges are not defined. It still has an area.
Okay, so I wasn't listening. I was a little bit distracted. Could you say that one more time? I apologize.
All right, have a look at this shape.
All right, so that's a non-geometric shape.
Okay.
Yeah.
So just about it still has an area. Right?
It does. Yes, it does.
Right. So my definition was, it's how much stuff you'll use to cover this.
Okay.
Cover this.
That's tough.
That's stuff. Yeah, it's a stuff. It's in quotes. So maybe somebody else can help me.
Okay. So really, yes, we can use. So let me just clarify that for you quickly before you
clarify the stuff.
That's tough.
Yeah, it's how much you would use to cover it, to cover this area,
yes,
to cover this shape.
All right, so if you look at area, we look at area every day because I can decide to cover this room with newspapers and then not necessarily squares, if you know what I mean.
Right.
So we can use anything to do a covering. But when we're talking about area, we think that the best form of covering is to use squares to cover because it tends to cover better than rectangular or triangular things. So for math, we tend to use that square covering to connect to it.
Okay, fair enough. Yes, I was just trying to, broaden it rather than be stuck with within squares.
Actually, that's why we use centimeter squares or millimeter squares and all those is measured in square units because
squares, yes.
Square is really connected to squares.
Right. Okay. All right. Well, I was using the manipulative. I was using as a graph sheet.
Yes, that's a good choice.
A graph sheet, and on the graph sheet you can draw just about any shape. And to get the area, the area covered, you can actually count the squares within the graph sheet.
That's a good activity.
Right? And you can also you could cut them to form the regular shapes.
Okay. Let's not say regular and irregular because I think we have a misconception between regular and irregular shapes. Because a regular shape, I can give some examples and then you can...
A regular polygon, yes.
Yes, so these are like equilateral triangles and squares. So what do you know about those two examples?
Right.
What do you notice about those two examples? I'm going to say an equilateral triangle and a square. Those are regular polygons. What do you notice about those?
All the sides are equal.
And what else? All the sides are equal. And what else is equal?
Angles.
And all the angles. And that's what makes it regular.
Regular, right.
Regular and so a rectangle is probably an irregular.
It's a regular polygon. So
the thing that we call regular is really non-geometric shapes. So for example, all the ones that are attached to a name, the squares, the triangle, blah, 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 pentagon, those are geometric shapes. Those are the ones. But you have the non-geometric ones, like a leaf would be, a shape of a leaf would be a non-geometric.
Right. So a leaf would also have an area, right?
Yeah.
So regular is the sides and angles are all the same?
Yes.
Like pentagon, hexagon, etc.
But all of those don't have to be regular. Say you have a regular pentagon. If you have a regular pentagon, that is telling you something in your head, that all the sides and all the angles are equal. So you have a regular pentagon and a pentagon that is regular. Yeah, so and because sometimes I do it too, but I don't know better, but sometimes I do it too. But what we call irregular is really non-geometric.
Okay.
Yeah.
So with the compound, let's say the compound shapes.
Yes, David.
We could cut them and put them together to form, like a rectangle or a square, and then from that we could actually see that the area is the length times the width.
All right. I like the graph sheet activity. I think that's a good activity. I'm not sure if I understand the compound shape one. Or let me explain.
Here's the compound shape.
Hold it up, let me see it. That's it. Yes, that's a compound. Okay, and then what you do, count them?
Count them to get the area.
Okay, good. That's good. That's a very good activity.
Right. And for the triangle.
Just give me
for
one.
the triangle.
Don't give me all.
Huh?
Just one is fine because I want to hear what the others have. Okay?
Okay.
Good. Very good.
Thank you.
Who wants to go next before we start on the Mona students?
Okay. I can go.
Who is that?
Diane.
All right, Diane, I'm hearing you, but I'm not seeing you.
Oh.
You don't want us to see you today?
I didn't remember to come back on.
Okay.
I will use our base 10. Our base 10 square.
Good. Yes, very good. Let's hear what you have.
And I will use my the units.
Mm-hmm.
And my definition is measuring the entire surface of an object.
I didn't hear
and I'll give them things to.
Can you give me the definition again? I did not.
Measuring the surface of a 2D object.
But the main, you're leaving out the main thing, number of squares. That is how this main.
Unit square. Yeah, unit. Unit square. And seeing that this already have squares all over them, we can use the unit squares and ask them to shade things on it, like 12 times 6, 12 by 6, and the next column will have them count on the base 10 itself, how many units that was actually, and they should have. So we'll do all sets, 3 by 4, all different sets, and then they will just record, they'll count the area, so they will see the connection between covering an area and actually seeing the area.
Okay.
Or they can, yeah.
Very good. What do you think?
And then they will see length times width will be easy for them to see area of, especially as it's a rectangular shape, length times width. Or 2 or 1 side times the other side will give me the area.
Okay, good. So one of the thing that we need to think about is that we have our Dean's block like we have those things. We can use them too. We don't have to go out and get the graph sheets or whatever, but whatever we know, we'll look how it says squares on. It is a good resource for teaching area. That's the idea. So that's a very good, I like that, Diana, I really like that you use the Dean's block, the 100 block, that's a being very, very innovative.
That's the only thing I had.
I didn't hear that.
That's probably what I had, so that's what I have.
Very good. Zana and Anya, Curly, so you just got here, so you didn't do anything. So Zana and Anya, want to go? Or do you want to do something else?
No, I prefer to do another topic.
I didn't hear that. Zana, I haven't been seeing you, no.
I'm there.
Nice to see you.
I'm just trying to finish up what I'm doing.
You didn't remember to come in here today. It's okay. We want to see you. No? Okay, go ahead, Zana. It's your choice. Okay, should I allow Anya to go first? Anya?
Okay.
Yes.
Well, what I did, no, I'm not well, so I have to sit down. I have a back problem. That's why I keep on blocking it.
Okay.
What I did was the same thing basically. It's similar to what's his name, Davy?
Davy, yeah.
Yeah, it's similar to what he did with the graph sheet, but like before I looked at the floor in the classroom, the tiles.
Yes.
So what I did, since tiles are basically squares, so I related to something they did, a real life activity. So I related to something they did, and so then I told them like if I had to find the area of the floor in the classroom, well, first to identify the shape story of the classroom floor, two-dimensional space. So then obviously they would count the squares, which are the tiles, and sorry, I just and then I'd ask them if they had to use like a unit, like a measuring unit, whether it's centimeters or meters, how would they do it? And then probably they would measure the area of one tile and then multiply it or whatever. And then we'll go to their graph sheets and they will realize that each square on the graph sheet is one square centimeter. And so we'll put a shape on it and they'll for them to realize like it's arrays, like rows and columns. So the length would be the rows and the width would be the columns. So if they multiply the two, they can get the area.
Okay, but
that's basically
the only thing that I wouldn't do, what I wouldn't do though, Anya, I wouldn't say to the student, because I would rather give them the activity. At the end of the activity, I ask them, then now, what do you think area is? Rather than telling them, we're going to find the area of the classroom. I could just say to them, okay, let's figure out how many tiles they,
yeah, like, right, after they did the flow activity, that's when they would realize what area is.
Okay.
And then I would basically do like what you called like you give them activities with the grid instead of I can't make them draw on the floor. You understand, to give them things to do on their own. I forget what you call it. You gave a name to it. I forget the name. Something task, performance task.
Okay, yes, that's a good performance.
So then we would, right, so we reduced like the grid on the floor, the tile grid to the graph grid. So they could do performance tasks on the graph grid. I don't know if you...
I do. So I don't have a problem with the activities. The activities, they are very good. I just want you to, I just want you to walk away with this idea that even though as a teacher, I have the idea in my head of what area is, but I don't want to walk in there and tell them what area is. I want them to deduce or observe and draw conclusions. You understand that? So when I give you the activity, I give them the activity and having them count in squares and probably draw something on a graph sheet and count in squares. And then I'm going to say to them, all right, what you've been doing today, you've been looking at areas and finding areas of different things. What do you think area is? You know, if you were supposed to define it, how would you define it? But not me telling them. But from the activity, they can draw that conclusion or make some deductions. Are we clear? That's what I want. So the activities are very good. I don't have a problem. But we don't want to walk in there and tell them everything. We want them to think and make the deductions, okay?
Yeah.
So, Zana, do you want to go, or should I just ask some of the students to give us, because they're working groups, to give us their thing, and then we'll move on?
To go to Mona, I did another topic. I did area, but then I prefer doing another topic.
All right, so we move on to Mona. Who wants to go for Mona? It's not different? Come, Ricardo. Just show them what you have. It doesn't matter if it's different. Bring your, So he's going to show us how he was thinking of using his you remember your geo template? Geoboard template?
Okay, class, it's not different from most of the activity that you have mentioned. Same, give them an irregular shape and ask them to count the number of square units And the ones that are not, for example, the ones that are not in of the required unit, square unit, you would ask them to probably count. If it's half or more, you count as one. If it's less than a half, you say 0. So for example,
Very good. Good job.
if you try a irregular shape on this, and you know that you're meeting the dots together, and you realize that here is less than a half, you would count it as 0. But if you see ones that is more like this one, this is more than a half, you count as 1. So by doing so, you estimate, so to speak. The word estimate. You estimate as you go along with the ones that are completely 1 unit, and that will give you a total. So it's not different from some of the ideas that you guys have mentioned. All right, the same idea we have as well.
Okay.
All right.
Very good. But I like that you mentioned that when you're the same thing, when you're looking at these non-geometric shapes, that's you have to do some level of estimation because it's not going to be accurately defined or accurate then. But you have to do some estimation. So a good and practical idea is to say, let's call these ones that are half or greater 1, and the ones that are less than a half 0. So eventually it's going to add up, to give you a good amount, all right, or near to the accurate amount. Good job. And so then look at perimeter, and then after we look at the perimeter and the activities that you guys come up with, then we are going to go for break and then come back and then finish up, and then we're going to look at the diagrams and hopefully do some work on our lesson plan, okay? We'll look at the diagram activities, all right, building spatial awareness. All right, perimeter. So I'm starting at UE because I started online, so I'm starting at UE Mona first. So somebody from UE. Yeah, assuming that you guys have something. Who wants to come? Yeah, you can, because you get the idea to come from the geometry first. So should I just allow somebody else to go or you come in? Okay, good.
All right, class.
So that's what is perimeter first.
All right, starting with the definition of perimeter. Or concept, I would say distance around.
That's a complete definition. Ricardo?
Distance around.
Okay, so
a shape.
So if I draw this on the board and I do that, is that the perimeter? Okay, so give us a better definition. The boundaries, you need the word boundaries.
Okay, so it is the distance around a boundary, right? Now, of a two-dimensional shape, to be mathematically
correct.
All right, so it's the distance around a boundary of a two-dimensional shape. Now, for me, one of the activities that I would give to the students is to probably use tape and put a diagram on the floor and ask them to use their footstep and go around it. So they would count their footstep going around that shape that I have on the ground. Now, different student foot will give a different measurement or number of steps. So basically from that, I could probably move away from the steps around the shape on the ground and use the gearboard as a standard unit now to say that when you were stepping around the shape on the ground, you counted your footstep. Now, if that same shape was to be on, say, the gearboard, we would now count space. So we'll count space right here. go
That will give
around,
it a perimeter.
and we'll get the perimeter. So that will be my input on developing the concept of perimeter to the student.
Okay.
All right.
Very good. So we've counted space, and we can walk around. So I like this one. A student told me that she used the ants. You know the ants analogy. You know, I have a leaf, and the ants is walking around the edges of the leaf. I think that was a very good one. Do you know that one?
No.
Yeah, but that's someone we can use. Yeah, so you're walking around the edges of the leaf. Who wants to go next? Any other activity? Any exciting activity? So you must be wondering, the purpose of this is for us to have these activities that we can use them in our own classrooms, especially for the ones who are teaching law school. All right? Anybody wants to go next, or we're tired and need a break now? Zana, it's your turn now.
Well, one of the activities.
I'm not hearing you.
The 7th, I think, our classrooms. You heard me now?
I'm hearing you now. I think you have some issue with your
Oh, it's showing me low connectivity. That's why.
Okay, okay.
Yes, I was saying that what with the grade 7 students, what some of my colleagues would do is they use the classroom as an example to teach perimeter. Have the students to stand on the lengths and the widths along the classroom, and on the floor of the classrooms we have tiles. So the students measure the tiles, and they use that to get the distance around the classroom as a form of calculating perimeter.
So you have the students. I was a little bit distracted with my mind. So say that one more time. Say that one more time.
Okay, what I'm saying is that we will have this because the classrooms are rectangular. So if you're going to do let's say you want to find the perimeter of a rectangle shape. So we use the classroom, the classroom in its real sense, as a real life example as to how to find perimeter.
Okay.
Right? So we use the on the floor there are equal tiles. So they use the length of the tiles, they count them for the length and the width of each side, and they add it all together to get the distance around.
Okay, so you would count. How would you know the length? You would measure it first?
We measure each tile.
Okay, so you measure the length. But I can see why you need the length and the width for the edges. But in terms of
right.
But you don't need the length and the width for each tile, but for the only
Not each tile. You would do the length. You do your length first. So if, let's say, for example, your length have 16 tiles, that would be your length. So you're counting the number of tiles to give you your length.
Okay.
Right?
So along the length.
But I would do the assumption that the tiles have a certain length.
Okay. So
all of them have equal length. And then you do the same thing for your width, for you count the number of tiles that will give you a width.
Okay, the number. Okay, I swear it's not. Okay.
Right.
That's clear.
Right.
Very clear. I thought it was for each tile. Sorry, my bad.
Oh, no.
That's my bad. My bad. Do you guys know very good, Zana. Do you guys know what a trundle wheel is? Anybody know what a trundle wheel is? Do you have the internet? It's a little wheel. But when you push it, it will click every time you reach 1 meter. You can look it up on the internet, trundle wheel. I don't know if a trundle or probably there's an H in there, so you can probably hear.
Is that what they use when they're building the roads?
Yes. So that trundle wheel, you can use it to do perimeter of like a netball court. So we have them at work. So you just push the trundle. So somebody can go and research. You can have it. You can get it to somebody to make it for you. So the distance around that wheel is 1 meter. So if you want to measure, so every time you click, you know that that's 1 meter. So that's something that you can explore to using your glasses for perimeter. I think it's called a trundle wheel. All right. And so now it's 4:30. You come back at 5 o'clock. I'm giving you a break. For those of you who are not finished, you now need to continue. You won't get a break. You now need to finish working on what is on the board.
What do you call that?
You'll get your break. Yes, David?
What I didn't get the name for that wheel.
Trundle, Trundle, trundle wheel. I was
okay.
not sure about the spelling earlier. It's called a trundle wheel.
Okay, yeah.
Go to the internet and have a look at it. It's good for teaching.
Yeah, I'm familiar. I'm familiar with it. I've used it to measure distances.
Yeah.
You know, to put up fiber optic cables.
Okay, good. So we can use it in the math class also to do pyramids.
Yes,
So
it's used to measure distances. Just walk along and push it along to measure.
All right. So if you want to know, for example, what's the distance from X classroom to Y classroom, you give them a trundle wheel and let them go and measure. So it's
let them go clicking.
Yeah, see, but you can just get one. For those of you who are teaching at the lower school level, you can get one. Somebody to make one, so you can have the students explore and use it. All right.
Okay.
And so, as I said earlier, you come back at 5:03. For those of you who did not finish your work, you need to stay and do it, and don't take a break. For those of you who are done, you're allowed a break. Okay. All right. See you at 5:03. David, I'll see you at 5:03 also.
I want you to do special awareness activity. Special awareness. Special awareness. I'm just feeling making fun. We are Volume one. Suppose I said we're going to use P. No. But volume, that P's and B with the capacity. Yeah. Remember, volume is measured in one cubic units and it's cubes. So there's a thing, there's a difference between the capacity. What's the difference? What's the difference? The capacity. That's a different thing. Capacity is a liquid measure. Capacity is how much it can fit inside. It can be piece, it can be solid, it can be liquid, but most times it's a liquid, but how much fit on the inside. Volume now is it's built in something the same size. So remember, if I want to find the volume, let's say somebody in the volume, somebody is 12. Instead of 12 cubes, the cubes will be done. So it's not necessarily how much is inside, it's how much. So it's not really done inside, how much. The volume of your cup is so yeah, so the capacity is how much you use. Use how much.
sorry, the volume of it is how much it's how much it takes to build a cup this size. So how much cube will it take to build a cup this size? So it's both internal and external. How much it was? How much it was? Simple. How much it was? So you never been up like one of those buses and the capacity is 200 and whatever. How much you can afford? Yeah, but they're two different things. It's a different. And then volume is cubic units. Capacity is not. That's why that's two different things. Because it's different to two different things. And then if it gets the same, it must be two different things.
Yeah, I'm trying to put it together. You have budget, dollar budget, 150 minutes. Yeah,
And it's like but the main bills I look for is the idea, you know, the bill. That's
obviously it's calculated, you know? So we all know to do that, you know what I mean? Yeah. What we can differentiate is the idea. What's the idea behind it? So that's what the thing that I will focus on really the content, the idea. As well as teaching them for the Is that all everyday social? So they have friends coming to Pittsburgh for work. Tell me about that. Every morning. And you say that. Oh, are. But they still have more than what's there. Yeah. Expensive. Like, and like, I don't know that age. Oh, that's okay. I mean, it's tiring because you're gonna give them influence for that. You're more scared to sleep and you understand traveling. Do you live on your own? With your parents? Yeah. It's like all your summer feelings for that train. That's so wrong. She's working. You should try some more. No, she was downstairs. Okay. Okay. Yeah. Back to what it takes also. Because for me, what I do, like, apartment, just to keep all of the things, something, like a clothes, I'm not wearing out because I'm not moving out. But I live on I do have like a tennis court and I have like a stadium or something. So I think you have to maintain. No, you really maintain it. So you have to be. Yeah, but I don't know how many yards it's like, but I do because that's how to us, like you have to keep them. But because I think it's work and then you have security. But I'm saying that it's but then I'm not that's how you think it. Really? What? No, plus. No. Okay, that's expensive than what you would normally pay. Like that. What you would have. No, that makes sure you do it fun. Yeah, cool. I don't have to. Everybody will use that. Everybody needs it. Yeah, but hello, Jolie. But can we, is we get the kind of nice of still, oh, it's always sleepy. I think it's kind of under like there's a lot of you don't feel a lot of it. You don't feel like there's a lot of water. No, that's exactly what I'm trying. The water is different, but we don't do that because the water is so yes. But even if it was so you have to pay some person who not pay, yes. Yeah, so it's cool. They will stress I don't have that place. I'm very slow. I was renting these, so like, what I think of my little was that I was living on time. It's nice when you go to get some place, but it's the area. It's the area of the convenience. Like something on home and it's like something on the gold house. And that's so nice. Even if it's just not just but sometimes it's part of like study and come up in the night like easily. And I like coming like McCarthy, this is it doesn't matter whether it's like 2 minutes of period. We're moving on. 4 years. 3-4 years. But I've already done everything. So I'm punctual. So if you're not trying to know when I go back, I don't know if it's I just don't miss that much. Like, oh, you know, it's new morning, they're coming over the body, you know, the first time's always big, but then eat food, the body, it's on. So it's something. And let's watch a few persons for dinner. So watch them, you don't joke. I guess, you must see what you're doing. So you don't know if I say, okay, so I think the thing, but some persons like, yeah, you know where you're coming from. Oh, wait, not like yeah, you have to tell me. It's like, come on. Oh, you can't do something. Oh, you know, stuff. Because somebody advised me to she said she had a friend. Her yeah. So you know the guys. I'm going to put in like certain things like orange and stuff like as pet food by more things that I should put like fish. Fish is oil. What about French food? Meat, what about pizza? Dairy. Last summer, I used to fresh. All of these are not square. All of these are not square. 1, 2, 3, 4, 5, 6, Sure. Of course. That's what I try to next to I don't think the rule. I don't mean it. What's my first study for your Level thing, yeah, it's a good thing. Yeah, because the conference, they have a conference every year, sometime in March, April, so you can do it at the school, but then send them for personal growth. It will cost you anything some because the thing about it up there, because it's in US for money. It's in US, and it's not always like New York or Florida. So sometimes you have to take a flight to New York or Florida, it's something else. So you can't go. And they go up on teacher. That's what it's. If they cancel everybody, then it's choose one, and the one person should go come back. I vote for it. Or they can rotate it through the time. One Harry said I'm a different person. This one is brought, so that's anybody in there. It's true. You can't listen to your movie. Person's development is good. They go in, learn new things. How are you going to get who's the department? But the jump is on up there. Oh, if I want to that school, I'm miserable.
what? It's not the teacher needs to review and come on.
Always. You guys just have your mind. Like somebody left for leave or something, and then somebody was interviewed, and he told, kept having to rough my
It's challenging. I feel like it's very challenging.
I like you, they don't face the one Oh, you managed that? That's I'm not going back.
Not sure what I was looking for.
Yeah, that was What first day I went to the grade 9 boys, went to this class, and have a teddy bear, and I didn't take some teddy bear. On the head of the teddy bear, there was something inside, and then I was doing it. And then the teddy bear head, and it's on the pen, and hold it up. You know what I do? You got to take somebody and put the head on after hold.
So I because they have some class at NG and the mechanics it's girls and one day I was walking in country girl. So the button is like the button one, but the thing is, I could talk to them because they use both the fun.
Yes.
But there was I was in the class and I said to a student, I saw call, said the college, they said, come on, you know, you're there, come on. It was an all boys out there, because it was at the engineer and mechanics, so those are the boys that do this. And I looked down, but the boys are moving up on camera, and the boys coming in. Like, you know, you can't be trouble to give it a mistake. I was somebody is that's proper as them. What is because I years ago, I'm saying that I'm here, but in money. Okay, I'm more time after I came, and I told her this girl, she started bringing this other. This girl is all over this is a lady paragraph from my friend here. I don't like the friend that you're on. She went back, so the girl went back to her. It's not little women. Huh? Immature little women. Immature. I couldn't do anything right. It got so bad. All of them are it got so bad. Then one get to the class. We call it team of man. Miss McCarthy. Really? Yes. They have some coach where like when we go to our first that's it. Oh, she's just again on the and I play here. So when you get to where that's going to happen. It's when she came up, we thought we were friends. Really? So she's talking to me. I used to talk to them like they can only talk. It's great for me. I said, there's people. So does that when you have a conversation with you, always talk to them like, okay, I'll do it, cool, I'll do it. But she would fight her friends and put me on fight up for her, blah, 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 blah. She had a research and I put it down. Because when I realized that she thought that we were friends and how we were friends. But some of them, they're old. And they explore also the girls in the sometimes when they're having it, yeah, to the cool thing. I use it for all. But they come to the store and say, "Call me." He doesn't count me this one. He calls me. And it was a staff room. I was there, so I did my orders. She jumped into the hill. She said, I said, "What do you here?" When you look inside the back of surgery. Bye-bye. All right, we're back. It's 5:04. We should have been back at 5:03. All right, so we're moving on to volume. Who wants to tell me what volume is? Who wants to start now? Caroline, can I start with you now? Because you weren't allowed to take any break, you know. You are Tasha. You weren't allowed to take any break. You were supposed to do the work. Right, Caroline? Right, Tasha? Right, so we're at volume. Curly, do you want to go, or do you have anything, or should I allow somebody else to go? Carlene?
Yes, I'm here.
Do you want to go, or should I allow somebody else to go?
You can allow somebody else to go.
Asha, do you want to go?
No.
No? You don't have any students, right?
I'm so not feeling well today.
Okay, all right. Diane, what about you? Diane? Diane,
Okay.
I'm not hearing you.
going? Kelvin? Okay.
Diana? No, Diana, it's you.
Me, I'm seeing somebody else on the screen. Concept of volume. I use it as space occupied by a three-dimensional shape. Measuring capacity. I did it from that angle. Measuring capacity.
But capacity and volumes are two. Capacity and volume, those are two different things.
Well, the capacity. Okay. Oh, well, volume. Well, I have no definition then of the concept.
You don't have any definition. Should I take it that you can't develop the concept because you can't develop something that you don't know?
No, because I developed the concept of what a 3D shape, a three-dimensional shape, in terms of the measure of how much the capacity, how much you can hold. So that's how I did my the second class.
So that's really the capacity you use, but it's not that you can use the capacity understanding to teach volume, but also I wouldn't recommend that because they're two different things and students can confuse them to be the same.
Okay.
All right, so I'll give you some more time to think about it, and then if anything will come up afterwards.
Okay.
Who is there? Sabina, are you there? Zana? All right, so it seems like we only have Davy or Jeffrey who can go.
Okay, I'll make an attempt. This is Caroline.
All right, go Caroline.
Okay, instead of capacity, I'll say the space, how much space the shape takes up.
Yes, but it really is how much space it takes up, but what unit do we use there for volume?
We use cubic inches.
It can be inches, but let's say units.
Right.
It can be cubic meters, cubic centimeters.
Oh.
So let's say units for it's not, but we use in cubes. So yes,
right.
Space, but how much space this three-dimensional thing take up in terms of how many cubes make up that would occupy that space? Is it clear?
Yes, it is. I'm trying to find my screen. Yes, it is. So I have you need 3 measurements for this one because it's 3-dimensional.
What do you mean by that, Charlene?
Okay, instead of just like the regular 2-dimensional, we use length by width. We now need length by width by height.
Okay.
Right. So to measure the volume, we would measure the length of, say, for example, a box. We measure the length of the box, the width of the box, and the height of the box. Am I?
Yes, but you're at the last part.
Pardon?
I think I'm missing something though.
Okay.
Nothing is wrong with that activity, but you're missing an activity before that. What's the idea is how many? So let me give you an understanding of volume. Or should I allow somebody else to go first before I start to?
Yeah, you can let somebody else maybe try.
Who wants to go, Davey or Jeffrey? Either of you want to go? Davey, what about you?
All right, I'll go.
Okay.
All right, what I have for volume is actually the amount of substance that the shape can hold, that a 3-dimensional shape can hold.
That's capacity.
Okay.
So one of the reasons why we measure, because if you look at the squares, let's talk about this first. If you look at the areas, we measure area, usually when we calculate areas, talk about centimeter squares and millimeter squares, don't it? When we find volumes, all we talk about centimeter cube, millimeter cube.
Right.
Cubic units, how many cubic units can build a shape that will occupy a certain number of space? So if I have a box, okay, let's say if I have this book, if I have this book, which is a three-dimensional thing, and I would probably say this is a cuboid, right? Agree with me? And I'm gonna say, if I need to find the volume of this book, it is how, we know how much space it takes up. So for me to find the volume is how many cubic units will take up the same amount of space as this book. Are we understanding that? That's the idea of volume. How much of the cubic unit will take up the space that this book will take up? When we start talking about that, is the reason why we measure volume in cubic units. When we start talking about capacity, it's how many, that's why there's a relationship between the volume and the capacity. Is how many things, so how many sand can hold, how many water, how many milk, how many juice, how much peas, whatever can fit on the inside.
Inside of the container.
Capacity, so that's the difference. So I was explaining earlier that so I'm going to use the 1,000, you know, this idea 1,000 centimeter cube is equal to 1 liter. When you're converting from volume to capacity, they normally give it that, this fact here, this is the fact, my fact. Are you following that? So the idea is if I have 1,000 cubes, we know little cubes then, centimeter cubes, and if we make a container with that cubes, both inside and outside, if we take that container and pour milk or water in it, it will hold 1 liter. Is it clear or not clear? So you know the little milk, I don't know what size milk container you have in the other countries, but I'm talking about Jamaica now, the little milk box, the little box milk, that is 1 liter. If you should rebuild that box milk with cubic units, we are saying that it will hold 1 liter of, something of that size will fit 1 liter of fluid. And if not, we can even use the cut off the top and use the little boxes to see how much of it can fit on the inside. So you can do it vice versa. But the idea is that if I make a container with 1,000 centimeter cube, that container will fit 1 liter of fluid, liquid, whatever.
Certainly. But that was one of the activities that I had. You know,
yes,
use
what you have.
Okay, so the activity that I have is to use these 1 centimeter cubes to build shapes.
That's a perfect activity.
Right.
Very good. You use cubes to build different shapes, and then you can count how much of the cubes, and then you have found the volume of the cube. Very good. Very, very good. Are you understanding? So you can use cubes to build anything you want, any 3D figure, and then you count how many of the cubes you use. Once you've counted the number of cubes, you've just found the volume of the thing. Are we clear? So that's the idea. We use cubes, so we can use different size cubes. We can use centimeter cubes, we can use decimeter cubes, we can use different cubes, and just build things and then count it. So if I use a centimeter cube, then at the end, my volume is whatever number of centimeter cubes that would have been my, if I use meter cubes, depending on what I'm finding the volume of, all right? So the idea is that we need to build things with cubes and then count them. That will give me the volume. Very good, David.
Thank you. I was trying to work out the relationships between different shaped containers that have they're all labeled with the volumes. So you have like a box of milk with a 1 liter.
That's the capacity in David.
Yeah, but but you still would be able to put the cubes.
All right,
to make
so
that
then
box.
remake it then. And you'll see that it's
Right, remake the box into a cylinder, like a bottle.
Uh-huh.
I was trying to work out that, but I didn't get very far.
All right. But that's the way you're thinking going. Very good. Continue thinking about that one. I think that's the way you're thinking going, David. So you're trying to convert the same thing. So you're saying that, is it that the volume would change or the capacity would change? That's what you're thinking of? That's what you're thinking of? If you have the same, no?
Well, okay, because I've gone with the cubes to show that the area, the volume of the cube is actually the area times the height.
Okay, so you're looking at, so you can look at that relationship. Okay, so you're
right.
Yeah.
Right.
Yeah, but because
So I was trying to take it down to well, I guess it works for the circle because you just use the circumference, the circle, the volume, the cylinder. You use the area of the circle times the height of the cylinder to find the volume.
Mm-hmm. But it's the same idea.
But right. It's the same thing when you just open the cylinder out, you cut the cylinder and you open it out. That would give you the circumference is actually the length. And anyway.
But you're going into surface area. You're mixing up the concepts. I think you should stop at counting cubes. Yeah, I think you should stop at counting cubes and then looking at the relationship, because I could build a box, different size box, different cubes, and then count how much I form the length, how much form the width, and how much form the height. And then, so I could have the count cubes and record how many cubes make up that box, 12 cubes, for example. Then I have them to say, all right, count how much along the length, count how much along the width, and count how much along the height. Multiply them. What do you notice? Do you notice that it's the same amount you come back to? So you can use that method to develop the formula for finding volume, which is length times width expressed for a cube. Length times width times height, or cuboid, okay? All right?
Yeah, well, I was thinking of different shapes.
Yes, you can.
I was going down different shapes, but continue.
You can use different shapes, but I don't want to mix the total surface area, which is when you open the box and you find the area.
Right.
Different things.
Yes, but I was thinking of like a rectangle, a triangular prism.
Mm-hmm.
We use the area of the triangle and then the height to get the volume of that shape.
Okay, so there's a relationship between
the area and the height. It's the area of the base times the height.
Mm-hmm. Yes, but for that is a little bit, there's a relationship between, if you have
It's an extension of the concept.
Yeah, that's an extension. All right, so let's just stop right here.
I've gone too far, sorry.
But then I see where you get to that, because I was going to show you the relationship, but I won't even get into that right now, all right? But
okay.
The idea is that the counting cubes, all right? So how many cubes make up this? How many cubes will take up the space of this thing? That's the idea.
Okay.
All right? So we're moving on to percentage. Nobody else want to tackle the volume concept? Or I don't understand my students are so hard working. I'm being sarcastic. All right, what's about percentage? What's the concept there for percentage? Well, guys, come on. Like, I don't understand. Like, nobody wants to share. I'm not understanding. Should I just say in the mean, demand more?
Is it letting the students understand that it is per, whatever it is, per 100. So out,
What do you mean by that
when,
exactly?
pardon?
What do you mean per 100? Let them know that.
So percent means for every 100 then. So if you say like 1%, it means one per 100. So for every 100, 1.
I don't know if I agree with that.
Pardon?
I'm thinking about that. Yes, Jeffrey?
Is it a fraction with a denominator of 100?
Yes, it's a fraction denomination. That's perfectly correct, Jeffrey. But I'm still thinking of per idea in terms of per 100. Yes, per 100. But I'm thinking about how the students, like what understanding the students will walk away when you tell them that a person is per 100, yes? Or out of 100. Is that the idea we want them to walk away with? Is that would that make, because the idea is that, if I understand this, will it really help me to understand percentage a bit better or get a deeper understanding of percentage? So I'm thinking through I'm thinking about it a little bit more. I won't say you're wrong.
Tasha here.
Yes,
what comes to mind is that another way of counting part of a whole. I don't know, that's what comes to mind.
Okay.
In terms of a fraction, turning it into a fraction and decimal.
Right.
Part of a whole. It's like Colleen said, part of per 100. All right. That's what comes to
mind. Yes, Anna?
I sort of understand what you're saying, because when you sit down there and you look at it, you're looking at kids and how are you going to get them to understand the concept? It's not really what it means, but understanding the concept of percentages. And I like the fact that Geffer said, going the way of a fraction of 100, the fact that they may have knowledge of fractions already, and understanding and seeing that the percentage is a fraction of 100. It becomes easier for them to see it and calculate it as opposed to just put 100.
Yes, that's the point I'm trying to make. But I said, let me think about it some more. Because when
maybe when you say fractions, you usually talk about breaking down into smaller parts, right? Yeah. So maybe you can say into 100 smaller parts, breaking down whatever you have into 100 smaller parts. Maybe that could help with Colleen's explanation.
Right, so I prefer the idea to say, because the students will already, they know, because when I say per 100, or all of those things, then they're wrong, if you understand the point. But how will that idea help students to properly have a deep understanding of percentage? So for me, the idea that I like is that it is a fraction where the denominator is 100, the one that Jeffrey stated earlier, because remember, students have been doing fraction from where primary school come up. So so if we show them how these ideas are interconnected, which is an important thing, then they're better able to understand. When I say per 100, that can be a little bit, I don't know. But I'm not saying that you're wrong, but I prefer to say a fraction with a denominator, because it has more meaning for me. That's what I would put it. All right?
Okay. What? Yes, I am understanding what you're saying, but when I said per 100, so out of every 100, then, so 1% would be 1 out of 100, which would be a fraction, 1 over 100. 25% would be 25 out of 100.
Yes. Yes, you're
so
correct. I'm not saying that you're wrong. That's the point. You're not wrong. So our idea is that what makes us a good teacher is when we can take these complex things, or these things that are hard and somewhat hard for students to understand, and make it very simple, or to connect it to something that they already know. That is what makes you a good teacher, to be able to make this thing look very simple. And so if you can connect to what they know, then it will be simpler for them to understand. So I'm not saying that you're wrong, but I prefer. So let me put that down. All right, so how did you go about developing the idea for percentage? What did we do? What are some of the activities? Come on, get moving.
From what we have done, I associated it with the base blocks. We can use the whole, the base blocks. Or we can use the fraction circles. Even graph sheet as well. We can construct using the little units where we can come up with 100 of them. We can shade just like the base blocks as well, where we have the whole ones. Maybe if we shade 5, it will be 5 out of 100. So it will be 5%. You know, we associate it with percentages. That's what came to mind and what I looked at.
Very good. So that's the idea that I normally prefer to collect it into fractions. So I would start by, if you have 100, great. And we understand the percentage is really a fraction where the denominator is 100. If you shade half of that, you shade half of that, you still have to shade half. How much do you think they'll shade? They'll shade what? 50. And that
50%.
So really, this half, they're equivalent fractions. If you're getting the point, they're the same thing. A half of that 100 is, half of that 100 is the same thing as 50 out of 100, so they're equivalent. So normally, that percentage idea can be connected to equivalent fraction. Shade 25, 25 of the 100, which is what? A quarter. Isn't it a quarter? So 25 of 100 is the same thing as a quarter. So you're making a connection between the fraction and the percentage idea. Right? So that's how usually I would start to introduce the concept of fraction, of percentage, because it's really a fraction.
Yeah.
It's really a fraction. Who wants to go? You want to go to Ricardo? Ingrid?
I have basically the same thing. I was just toying with how now you get them to move from that to the notation.
Because look here, if I have so this thing, once they know is that once they say a fraction where the denominator is also the same thing as 50%. They're the same, yes. Not so this is a fact now. It's not math fact. There's nothing you can do. You just have to tell them this. So you have math fact. So there are facts like this sign that we call with a cross or a T is a plus. That's a fact. There's no developing that. So there are some things that are called math fact that we just give them and they have to just know these. This X here in math, it really means multiplication. That's also a math fact. So this is not a math fact. So when I see that this is the same as this, so once I have this, I can interpret this to mean that. Well, anything I have, even if I have a half out of 100, I can interpret it to mean that. It doesn't matter. It's the same thing. So once I see that this and this, they're the same thing written another way. You know what I mean? So once the denominator is 100, it's a percentage. So you can have a deeper understanding than just, All right, are we done with percentage? I will finish. Anybody else want to share? Dave, you look anxious like you want to share something. All right, go ahead. I'm waiting. I'm going to set up my laptop for the next activity. Yeah, we're going to do the division. Want to share percentage? Oh, we're done with percentage.
Miss McCarthy?
Yes, ma'am.
If after you taught them all of this, you give them a problem, you help them, and you work your way through the problem with them, would that be okay as well?
Yes, you could do that, or give them a scenario or something. That's part of the...
Yes, that's what I did after I moved on from the step you had there, about showing them the symbol, and then if I give you 3%, then that's 3 over 100 and so on. I was thinking of giving like a problem in a survey. 1 in 5 people said they preferred a particular brand of cola. What is this figure as a percentage? And then I would...
So this 1 in 5, they need to write this as a percentage. So all they
yes.
need to recognize, so they know that all they need is a what? An equivalent fraction for this.
Yes, to get it, to have a denominator of 100.
Okay, yes, that's very good. That's it. All they need is just an equivalent fraction for this. So even when we say to them, all right, you get a test, you get 16 out of 20. What percentage is that? All you need is an equivalent fraction. You don't want to go in that box there. How did you move from here to here? You multiply by what? By 5. So you multiply this up by 5 also. Or you could go ahead and cross multiply. There's several different things you could do. All right? Good? Division. I'm sure everybody would want to share with me for division. Everybody must want to share for division. Please don't let me have to beg you to communicate with me. All right, so
Can we start with Mona?
Can
we start with Mona?
All right, go, David.
No, we want to start with Mona.
All right, Mona, let's go. Mona, they want the vote for you to go and start. David's a part of Mona. David, you hear the politics that you're getting me in now? They're saying that you're a part of Mona, so you need to start. All right, one of the 3 Mona students, can you come to the board and start division for me?
Yeah, man, we need to see the Mona students. Those of us online need to see the Mona students.
You're not a Mona student.
Not today. I'm an online student today.
You won't get that chance again.
All right. For division, I also bring out the concepts. So first, we want to define what is division. All right, according to the good literature, it said division is repeated. Good literature.
Good literature?
Math literature.
Where's the math literature? Where's the math literature?
Books from books.
Okay, all right, go ahead.
All right, according to the books, it said division is repeated subtraction. Therefore, normally one
of the concepts, there are several concepts.
Yes, there are several concepts
for
division. Mm-hmm. All right, because division can also be as concept as fraction and so forth.
Yes.
Equal groups. All right. Well, for me, the first activity I would give them is give them counters or diagrams. And I would probably ask them question, how many groups of 2 or 3 can I get from those sets of counters? And I don't know, bright children to probably try to probably circle. Yes.
Okay.
Shouldn't that be equal groups? Ricky?
Yes?
Shouldn't that be equal groups?
Yes. Tell us how many equal groups.
Yes, tell us how many equal groups you can get from a set of counters that you give them, and they will do their little partition or counting. So we count.
Actually, it's this idea of division. Is this how many groups are sharing this? How many groups?
How many groups you can get from them?
So yes.
Equal groups. Okay. So I have 10 divided by 2. We can never understand that.
All right. You feel something?
Yes. No. So we have our. For example, you are given a number 6, and you ask how many sets or groups of 2 you can get from 6. Normally, the student will draw, or you can ask them to draw or give them counters, and they would make a representation of the 6. After they have done so, they will now count how many groups of 2 they get from the number to the quantity. And they will count and say they receive 3. Now, how I show them to do it based on what they have done with the counters is to write 6 minus by 2 will give you 4. 2 minus 4 give you 2. 2 from 2 give you 0. Now, how many times do I use the 2? I will count it. So I will say, I use the 2, 1, 1, 2, 3. Therefore, 2 divided into 6 will give you 3 sets of 2s. So that is how I would give them the idea. I'll give the activity. Everybody clear on it so far?
Are we clear?
Yes, we are. Yes.
All right.
Yeah, Ricky, I understand where you're going, but that the multiple equation, multiple equal signs.
Is an issue.
It's a big issue.
The math center.
6 minus 2 is not the same as 4 minus 2.
Oh, I mean, no, we do it continuously, so we could probably
put it on a different line. Yes.
So we get 4 as a 1 to minus 2, we get 2 from 2, we get 0. So
right, you have the 3 2s coming down.
So I know you're very good. So we call the number of 2s we get 3. So that is a typical idea, activity that I will give to the student, and they will say the answer from it.
Thank you. Good job. And so if I have a bigger number working with, give me a number. All right, 24 divided by 3. Right. So we are assuming that could take a very long time, right? That's what we're saying, right? But what are the purposes for doing division? Before our students will do division, they would have to do addition, subtraction, and multiplication, don't it? So the idea is that we're taking out groups. So I don't have to take out one group. It's easy for students to take out 10. You can take out 5 depending on your multiplication skills. You can take out 100 groups depending on how big the number is. So if I look at this and I know that 10 times 3 is what? 30. Can I take out 10 groups? So I can have 36 and I'm taking out 30. And this 30 is equivalent to 10 groups. Agree? 10 groups of 3, yeah, same thing. Now this one, my remainder is 6. I can take out one group here. This is one group. My answer is 3. I have another 3. I can take out another group. So this is another group. 0. So when I add how many groups I would have got 12 groups. So sometimes we're thinking that the number is too big. But once they understand I can take out 10 groups, I can take out 15, depending on the 100 group, then it's easy for them to work with. You don't have to be one, because if I'm trying to take out one group, then this is going to be very time consuming. But the idea is that you can take out any amount of group you want. You can take out 2 groups. Because if I've got here and I can know that 2 times 3 is 6, I could have just taken out what? 2 groups here. So you can take out a different number of groups. All right? Dave, you look confused. So please give me a comment.
Can we use our multiplication facts to assist us with solving this faster? That's another concept, using your multiplication facts rather than just. So you start maybe how, according to your place value, your digits, if it's thousands, hundreds, tens, you understand? The bigger your digits, you go accordingly. So you have 36 there, you start with your tens, then you start with your ones, right? So using multiplication facts can also assist you. That's a concept.
Yes, because if you have 30, how many 3s can you get to the 30? It's going to be 10, then you have the 6.
Because it will be time consuming to, yes, it is a concept what you're using there, but it's time consuming as well.
Yes, but remember now, building concept is definitely take time usually.
Yes.
But students know how to properly use it.
According to the grade level you are teaching again, huh?
Yes, so it doesn't have to be consuming, because the average grade, let me put this, the average grade 7 student don't need to do this way. This is the point I'm making. Probably if you give it to the primary level, depending on what grade they are, they might need to do it this way. But the idea is that we don't want to just walk away and just just doing an algorithm and don't have an understanding behind for it. Don't know why to do this. As I was explaining, I don't like the long division, even a short division concept of doing this. And then we go.
You say free. How many groups? Free into free. That's one group. One group, right?
But
free
it's
into
not
six.
really a 3.
Yes, and you bring it.
It's not really a 3. That's 30.
Yeah. That's what I'm saying. The 10, the place value, free. We're gonna go into place values here.
But if I had a 0 here, it might be hard for some to see how many times 3 can go to 300, depending on what the number is.
Yes, quite agree.
So that's the reason why I don't do this method, because this is not really a 3, it's really 30. And when I get 3 times 1 is 3, I shouldn't be subtracting from 3, but I should be subtracting from 30.
Yes.
Are you following what I'm saying? And then I bring down this and I call that, I said 0 and carry. So there's something that is wrong with this algorithm, because it's telling a lot of math lies. It's not consistent with math, like math facts and math truths. Let me put that back. But it's optional. You can probably I would suggest, before you can use this, you should explore the different options and then probably say, you can do this, but it shouldn't be the first choice. Huh?
Yeah, okay, I'm saying, okay, so it means.
Yeah. There are too many lies in this, too many rooms for misconception. All right? All right, so the last one we're at length conversion.
Mrs. Mark.
Mrs. Mark, I'm not married to my father. But
Mrs. McCarthy Curvin. Mrs. Curvin.
Yes.
Higher grades. Division by fractions. Can you address that for me, please?
Like what? 6 divided by a half?
Yeah.
Talk about that already.
You did? Oh, I probably missed it.
We did. We remember how many halves can I get out of 6? We talk about that when we're doing fractions. You missed the class, go watch the video. And then we even went and we talk about why reciprocate, so go and watch the video. Okay, and I see you're turning over. All right, so the next thing we're moving on to is length conversion. So David, your responsibility to watch the video and tell me about when you watch it. So moving to length conversion.
I'll go.
All right, go.
I'm trying something.
That's what we are doing, trying something.
Yeah, my concept is a change in the form of a measurement expressed as a different unit without a change in the size or the amount.
Oh my God, you're so brilliant. You're so brilliant.
Okay, thank you. Whatever.
Because you're right, what you're really doing is that you're writing an amount, it's the same amount, but you're writing it another way. That's the simplest way. It's basically exactly what you've said, but it's the same amount. I'm just expressing it another way. So if I have 80 or 86, I can express it as 8 plus 6, but it's still 86. Very good, I'm impressed, good job. All right, how did you develop that concept?
Bring your metric ruler. If you look at the metric rulers, there is centimeter on one side and millimeters on the other side.
Huh?
Yes, the metric rulers, they have centimeters on one side. Yes, and the next side is broken up into the 2 millimeters.
I'm gonna check that one.
Yes, check it. Yes. And if you just take out your ruler, you will
it will take 10 of that millimeter to make the centimeter. So I don't see why one would be on one side.
No, if you look at both one side, there is 1 centimeter. And if you look at the other side, you'll see it broken up into smaller little lines. 10 smaller little lines.
Okay, well, I guess you're
not your ruler, baby.
Yes.
But I've used that before. So it's I don't know. It's from the physics lab. So maybe it's in it's scientific something. But if you use those rulers, it's very clear. The 1 centimeter on one side, and when you look at the other side, you see the 10 smaller little markings. So you can clearly see that 10 millimeters is equal to 1 centimeter. And you can have a whole lesson. So how much is 20? They'll see 2 centimeters, they'll see the 20 little spikes and write it down. And so they'll have like a rhythm and just finish. Use the entire ruler and understand that basic confusion.
Okay, good. So they're looking for a pattern then. That's what you're saying?
On the ruler.
Okay, you're following that idea? So she's looking for a pattern. So when she look at this, the 1 centimeter is equivalent to 10 of the millimeter. The 2 centimeter is equivalent to 20. So they're seeing the pattern. All right, so I like that idea. So when you look at a 3 centimeter, it's equivalent to 30
little spike. Yeah.
Okay, they're seeing the relation.
And you can ask it back and forth, you know.
Good.
You can say, if I have 40 little millimeter spike, how many centimeters? And you'll look at the ruler and give you the answer.
Okay, very good. I'm impressed. I like that pattern, building that pattern thing. Anybody else? Yana, can I ask about the mango?
Hello?
I thought of using the jeans block.
All right.
Hi guys, how are you? I thought of using the Dean's blocks. So we could use it, well then let's first out into 10 units, and then we could have the 10 smaller units.
Good, very good. You all are right.
Okay, so they would see that 10 of the small ones make the one big one. Yes? And then now I could develop on that by asking them if I were to have 2 of the long ones, how many of the small ones would they need to make that new length? So if I put 2 of these, how many of the small ones would they need to make that length? I could ask them if they had 30 of the small ones, how many of the long ones would they need? So they get the idea of converting from the bigger or the greater length to the smaller one, and from the smaller one to the greater one.
Very good. I think one of the ideas that I normally use is a string. You know, you can use a string. Yeah. So you can cut the strings in different, so you can even fold the strings and show them it's 10 of this and equivalent. So let's say I cut different size strings. Are you following that? We could cut different size string and then we can fold and see how much of which one, how equivalent they are. All right, so the idea that let's say 100, all right, 100 meter, give 100 meter, wait, I'm this time this is my head. No.
100 centimeters?
100 centimeter meter, yeah. The other one is a kilometer, 100 meter and a kilometer. All right, that's too long to far to decide. All right, so if I'm saying 100 centimeters make up the meter, we can have an idea what a centimeter is and what that distance should look like. You know, so you're giving them a visual picture of it. So when you're asking them now, if I'm coming from centimeter to meter, should it get more or less? So the idea, so after you come from this, you want to say, all right, if I'm coming from this unit to that unit, should it get more or less? Once the can determine get more or less, then we should decide whether they're multiplying or dividing. If it should get more, then you're expecting it to become larger. Agree? You should get, say, if to multiply. If you should get less, you're expecting them to do what? Divide. So the idea of more or less is also important. point.
I have a question. I have a comment on that though.
Yeah.
Isn't that like a misconception? Because you're just saying that if you have a meter, you're telling them to go to centimeters, you get more, but it's the same thing because you're not changing the length. And that is what I teach physics as well. And a lot of students, when they have to convert in physics, they come up with that. They think like they're thinking like, for example, a micrometer.
More or less in terms of, is that more or less in terms of the, yes, it's the absolute value there that I'm talking about. Does that absolute, say if it was a 3 and it becomes 30, it's the same amount, but the absolute value change, the value there change.
I'm not saying no. One thing is when teachers use what you just said, like for example, like if you reach on millimeter and meters, for example, and remember you said you use the string, which is what I normally do for meters, and then I tell them, I don't make them fold it, but we take like a pencil and we just mark off, and they will see like you can separate it into how many centimeters and stuff like that. So then that way they realize that 1 meter is 100 meters. But then some teachers, like, because centimeters is less, you get more. And then they don't understand. When it comes to physics now, when I'm talking about micrometers and things they've never seen, they will see, okay, I need more micro. They see it as a different quantity and not the same thing. They're just saying in a different way.
Okay, I see. I definitely see where you're going, which is a very important point. I see where you're going. But if we're coming from the idea that we explain that it's the same thing written another way, we're talking now about the value there, like probably not the value, but that number, the size of that number increasing, not the value because it's equivalent amount, it's an equivalent amount. But that 3 that would move to a 30, that's what I'm saying when we talk about more or less. So probably it is how we verbalize it. So I definitely understand the point you're making. So probably it's how we verbalize it instead of, we should probably make complete sentence to say that instead of saying, is it more or less in value, but the size of the number increase, however, we realize that this is the same amount, all right? So, but it really is the number getting larger, but it's the same amount, of course, it's equivalent amount. I don't know if that is confusing, but I definitely understand what you're saying. But the number really increased. I understand your point. It's a very important point. Very, very important point. Very important point. But probably just talk about absolute value in terms of the number. Okay? Can you come up with a way we can verbalize that a little bit differently?
Oh, well, I do get them in ninth grade, like what I do, but we cannot teach it. Like, I understand what you're saying because sometimes there are certain ways you can teach a level because they don't have the prerequisites. So by the time I get them for physics and we teach conversion, they have already done indices and exponentials. So it's easier for me to tell them like the word milli means by 10 to the negative 3 and stuff like that. So that way they see now that they don't change. And so they don't change the actual value because it's not about, the thing is when they get that knowledge that 1 meter changes to 100 centimeters, when I reach on units that they do not know, they see it as a changing and not equivalent. So what they would do now, they would think that micrometer is actually a bigger value than what is a longer measurement than a meter. They would see it like that instead of it being smaller. That's why you have so many zeros before it.
As I said before, I think that's a very important point. I think that the way how we introduce in terms of, yes, when we look, we can say it's equivalent, but it takes more because the idea is still the same, and it takes more of the little one to make the big one. So it is, yes, it's the same amount, but it does, if you look at it, it does take more of the little one to make a bigger one. So maybe it's thinking now, how do we verbalize it? So if we start here, they can visually see it. Yes, it's the same amount, but it really takes more of this to make this. So probably I think that what we could think about is how to verbalize the students, get the idea that it's the same thing, but yes, it does take more of this to make this. Because for them to
so that's why I think it's important for the manipulative because manipulative will show them that it's the same thing. But then some teachers, they don't give them that equivalent thing, like to show them that you divide it into smaller pieces. They just come with the algorithm, bam. And so they don't see it as they converting, but they see it as, okay, I'm increasing this to a bigger number. So they don't see it as equivalent. If we have the piece of string, that would be great because they will see I haven't changed anything. I'm just saying it a different way. But instead, like if we just come with the algorithm now, they're thinking you're changing something. It's not the same thing you're writing, just in a different way.
Okay, so probably it's a method, as you said, but probably it's a method that you're saying that if we just do the algorithm, then that could.
Yeah, that's what I was saying. That's like as you were explaining it, I realized where the misconception could come. That's why I get the problem when I try to teach conversion in the higher grades.
But even with the string, even when you follow the string, you show that it's 10 of this that makes up this one. 10 of this that make, is equivalent to this one. They're saying that yes, this 10 is more, but it's the same amount. So there's definitely a relationship between this more amount and this that are the same, that are equivalent. So I don't know how else, I do understand your concern, but I probably need to think about it a little bit more, see how else could we put this concept across for students to not thinking, like probably it's how you introduce it, because if you're thinking that, if you're introducing it as, all right, it's the same amount representing another way, if that's the underlying concept, the same amount representing another way, we're expecting them to walk away with that because that's the concept. But I don't know how to express it, but definitely, because I'm seeing equivalent, but I'm still seeing more to make that. So probably how you introduce that would have made a difference in terms of just giving them, all right, so how many centimeters make up this and how many that make up that. You kind of show them that it's an equivalent amount, even though you can distinctly see that 10 of this little one make up the big one. It's the same relationship like the Dean's block. It's the same amount, but it's 10 of the little one that makes up the long one. So I really don't know how to deal with this, but I still do understand the concern, which is a very important concern. I can relate. I understand your point. I do understand your point, but I probably need to think about it a little bit more. I don't know. Any input? But I definitely would not say it is a misconception. I definitely would not say it's a misconception. Any comments? Any comments at how we can fix the problem?
Would they have been introduced to units, the size of units prior to this? They would have, right?
Yes, they would have.
So they should understand that
it's a smaller that makes, so it's even though it's the same amount. So I don't know, so
you should take more of those to cover a long distance.
That's the point I make it. It would take more because when you're looking at meat, like let's say you have a meter stick. And you have the meter stick for say, all right, 100 meter. What does that mean? 100 of this is going to make up that, if someone run 100 meter. If I'm talking about meter and kilometer now, and then that distance that we call a meter is a how much I make it 1,000? 1,000 of that would give you a so yes, but it give you there's some equivalent, but it must take more of the little one to make a big one. Unless the
division by fractions.
Huh?
Division by fractions.
Probably we could talk about the relationship
between division. It's fractions. It's the fraction. It's a fraction of the bigger one, so you have more of the fraction to make the whole. Yes.
Yes, and that's how we can verbalize it then to kind of avoid that misconception. So I'm talking about fraction. It's a fraction of this, it's a fraction of this. So I like that, David. That's probably we can talk about it like that to avoid that misconception. Anya? I like that concern though, Anya. I see your point. It's a very good point.
Yeah, it's not, the thing is, it's not about, I think you misunderstood. It was something that was said. They said it was like they're saying from smaller to bigger you divide, and from bigger to smaller you multiply. And then that is stuck in their head. So when you tell them to divide the numbers, they don't see it as the same. And that's something that is very, because if for physics, for example, you must convert. They cannot escape it. You have to convert units. So then they don't see it as equivalent. They think they're changing the units. Like if they're doing an experiment, they're thinking they're changing their values, their data, and what they think they're doing. But they're not seeing that they're just writing the same thing in a different way. Because in their mind, they think you have to multiply to bring it somewhere, to make it something else. Because what they were taught. So that is what I'm saying, that if they're taught that like that, they're not seeing it's the same thing they're doing all the time. So that was just it. Because when you try to teach them things like changing mass to weight, it's just beyond them after that, because they don't understand what's going on. They just know they have to multiply, they have to divide, and they don't know why they get confused.
I know, because
so that was the thing. Like
I understand. That's what I'm saying. I do understand your concern, which is a really important thing for us to take into consideration, because part of teaching the subject, is to think about all the misconceptions that they could gather from a method. You know what I mean? So nothing is wrong. So I like that you're saying that this is the issue, so we can talk about it. This is how they see things. So we can talk about it here. So I think that I like David's idea of saying, instead of saying it takes more, start using the word fraction, all right? So probably that's one way to put it.
Yeah, I understand that, because I like that idea. Like if the in the lower schools, because unfortunately I don't get them at that stage. So if in the lower schools, instead of just teaching them the algorithm, they actually show them that, hey, we're just dividing this into sections. So therefore, we just, instead of saying 1 meter, we're saying, hey, it's 100 centimeters, or a centimeter is now the divisions. And then we're saying 1,000 millimeters, because millimeters is now the divisions. We put that same 1 meter into.
Okay, so even just saying that, all right, even though the number here is bigger or more, it really is, at the end of the day, the same equivalent. It's equivalent, all right?
Right, it's the same thing.
It's the same thing, which is the basic concept behind conversion. It's the same amount written another way. All right, well, that was a very rich discussion. Any other comment before we move on? Nobody wants to add anything? Come on, you all must have something to add in that discussion. Nothing? Tasha, what do you want to add?
I'm clear.
Okay.
So far, everything's good.
Jeffrey, want to add anything? Caroline?
No, it's clear.
Zana?
It's clear.
Okay.
It's clear.
Sabina? All right, and you guys. All right, so we're gonna do let me see if I can put it up and all of this. No. Not take? I need to. And so let's take us our tangram pieces, please. So the tangram pieces are the 7 pieces. Do you remember that? We're going to take that out quickly. Yeah. Where were you to come and help me? I don't have a projector anymore. Come and look at me. Oh, it's fine. All right, so we're going to do something. We're going to, I'm waiting for my computer to come out properly. So what we're going to do, we're going to look at designing some things with our tangram pieces, just to see if we're spatially aware. I don't know if you're all of issues with being spatially aware. Yeah. All right, so let me go and find the activity. Where's the remote? I don't understand. I don't get a remote. Blank screen. No, it's blank screen. Is it blank screen?
Oh, you want blank screen?
Yeah. Let me just try to solve this up. Yeah. Because I'm not there, we'll just leave the virtual mode. I'm coming like thing bothering me. I'm coming. I'm coming by something. Yay, I found the Eureka. All right. So this is the activity. We're going to use our, can you see this?
No, bring the camera down a bit. We can't see the top.
Oh, we're going to share screen. All right, so do we have our tangram pieces? Can you hold it up? Let me see it. But you don't cut them, you cut out yours. Like, oh, you have the 7 pieces. Good. So what we're going to do, these things, they were made with the tangram pieces. So you're going to look to see if you can reproduce them, all right? Do you understand? And it is really, might seem very easy, but it's not so easy for some persons. So it is really building your spatial skills, okay? Is Mr. Charleston?
Oh, you want him to be?
No, that is my. So open to export the things they remember.
Not to let this I've been at this thing for a long time, and I've got something I am.
So listen to a lot of Christians.
That's why.
Yeah, man, I love Dr. Charleston. Spiritually wise.
I think so much that I do.
So you just want us to share one thing?
Yes, just share it for them.
Yeah, that's right.
All right, so we're going to try to reproduce some of these with our tangram pieces. And when you feel like as though you're finished, we can do I need to put it up there? No? Let's try. Try to reproduce it. I know. You were saying something about honest stress, trying to figure out my thing. I don't remember what I was saying. I think it was about assignment. Okay. You have until the class ends this Friday or the next Friday to submit everything. So you know you can do it by next Friday. Okay? And it's not like it's a last. That's next Friday. You can do it. This one of your own shape. No. I'm going to get it turned like
That's what is a practice. This is not right. But I want to see the shape of a trapeze. Sometimes it's like very quickly. It's not that I'm just gonna figure out how this one is. Unless I can help that. And even then it doesn't have that long. So I get another one.
It's fine, it doesn't matter. I just wanted to practice.
No, I still have to figure out how to figure that last piece on number one.
Tasha? Tasha?
I'm here.
How are you doing?
I'm getting there. I'm almost done with the first one.
Okay. Zana? Zana, are you there?
I am here. I am here.
How are you getting on?
It's going okay, you know. But do you need? What I was thinking is that you only one piece, only one page we had to print, and we do them separately, or we need them more.
No, man. I just try any one you feel like trying, or two of them.
Oh, okay. All right. Okay.
So you would make one, and then just because this is just for you to kind of see how spatially aware you are. It's your personal thing. I just want you to work on it. So probably you can make one, and then when you feel like you've achieved that, you can move on to 2 or 5 or something, you know?
Okay. No problem.
Okay, it's just for you to explore. No, but you can use the because the rectangle too. But you can make a triangle with these things. It's too big. You don't have a triangle. It's the 2 triangles and a rectangle. It's 7 pieces they have. It's usually 7 pieces. Hello. It was two triangles. Two big triangles here. These are the two big triangles, you know. This one and this. Two large triangles. There are two large triangles. These are the two large triangles. See that? Coming right here. You see that? Hmm? What is it? Does it help you? See, that's not what I want. No, his head is up here. I don't want to do that. I don't need it. I just did it. I finished it. I want to do it. I just figured, let's see if each part properly. That's I just figured. I know I can't forget those. I just got to follow that. You know, the children, some children are really responsible for themselves, even because their children are not children. Not children. They don't have mixed up with it. They're a teacher. You married? I know. Are you sure? I think I'm sure. But I probably can't answer that. That's funny.
for 6 work and at least for 4. You can whatever it takes to get it. Tell them need to be overrun. So you're teaching primary and 21st and 12th. need more than 2 sets of feet. More than 1 set. This is 1 set.
So that's 2 triangles now, or square, what am I doing? That is like 2 triangles or something.
Okay, let me just try this. And then now
What the big triangles are? It's one of the big triangles. The 2 big triangles are right here now. This is actually
not that one, not that one. The one that's marked.
Oh, number 2. Oh. I don't know what
the part at the top. Looks like it looks like I need 2 sets.
No, that's the best one.
Then you can put this square in the top. And then get there.
All right, I'm going to stop you guys. All right, so how many did you get done, Tasha? How many could you complete? Tasha, can you hear me? Tasha? Zana? Anybody?
Hi, I'm there.
Is that Zana?
Yes.
How many did you get done?
I got 2 done.
Okay.
I put them together like 2 different paths.
Okay.
Well, the others look everything, so I just tried 2 and I left it as that.
Okay. All right.
Yeah.
Tasha, how many did you get done? Tasha, can you hear me? Jeffer, are you there?
I'm there.
How many did you get done?
I got 2 done. I'm trying a 3rd one.
Okay. Diana?
Hi, Sabina. I'm here.
Sabina, how many did you get done?
I got 4 of them done.
Wow. Did you take a picture?
I didn't do the first one, but I did 3 of them. I have photographs of 3 of them.
Okay, good job. So, Diana, I'm not hearing you. Are you there? Carlene? Carlene, are you there?
Yes, I'm here. Well, I only did one. I did the second one. No, the third. Was it the third one? I did one.
Okay. All right, so I guess we'll continue to work on this another day because I need to basically ask you where you're at with your lesson plan. So if you have any question, and then basically I'm going to close the class because it's 18 minutes to 7. I'm going to close the class. So we're going to have I'm just going to take some questions in terms of what you have so far for your lesson plan and if you have any queries. If you don't have any queries, you all get to go 18 minutes early.
Well, yes, I completed the lesson plan, but I was hoping that maybe, can I send it to email it to you so you could look at it?
You see, I don't want to tell you that because it's not guaranteed that I'll get a chance to look at it before. So I don't want to tell you that I don't get a chance to look at it. So that's why I prefer for us to have a discussion because you might send it to me and because I have several other things doing, I might not get a chance.
Okay, well, let me tell you what I have there so far.
Yeah.
Well, the topic you gave me, what I selected was algebraic expressions, right?
Yeah.
But my subtopic, the specific topic is algebra, but my subtopic, I put it in writing and reading algebraic expressions.
Okay.
Now, I'm not sure, but I'm saying that usually we introduce
For a subtopic, maybe it should just use expressions.
So just take out the writing and reading, just leave algebraic expressions.
Go again?
Just leave it as algebraic expressions.
Yes, you could do that, yeah.
Okay. But in my objectives are basically going to spell it out anyhow.
Yes, yes.
So I have my prerequisite knowledge. They will need to know addition, subtraction, multiplication, and division of integers.
Yes.
They will need to know some of the terms used in math, such as sum, product, factor, coefficient, and quotient.
Okay.
And I don't know. And they will need to know what is an expression in mathematics.
But isn't that what you're going to teach?
Yes, but then what happened is that we don't want them to. Well, the reason why I say just not algebraic expression, though the word expression. They will need to know what it means in mathematics, meaning that a statement without an equation, a mathematical phrase.
Okay. Okay.
Yes. So what I have there is upon completion for cognitive. I have defined the terms variable, written expression, numerical expression, and algebraic expression after exploring an exercise explaining the different aforementioned terms. So what I plan on doing is to have an exercise where we'll be exploring what is a variable, written expression, numerical. I have the steps in my developmental to show how we're going to go about defining these terms. And the second one I have is identify parts of an expression using mathematical terms like the sum, term, product, factor, quotient, and coefficient.
Okay.
Psychomotor, I have construct a table, mapping expressions that record operations with numbers and with letters standing for numbers.
So when did they read the expression? I thought you were thinking when you said read and write expressions, I was thinking of like a worded question, like something like that.
Yeah, it is there actually.
But you have
and that is where I have.
Remember, you have 15 to 20 minutes. That sounds like a lot of objectives for 20 minutes.
Well, what happened is that with what I did, I timed them with the define and the first two. The second one will come as an activity. That would an activity after explaining the types of expressions, the expressions.
Okay.
So the second objective will basically be an activity that will be taking place to achieve the second objective. And for my effective, I will use it in the plenary. Connect what was learned in lesson by completing an activity that involves students' individual problems. So in that, so not plenary, sorry, that would be more or less an assessment of them where I give them, for example, what I did, I say I'm giving you one letter, two numbers, and you can choose any operation where you come up with your own, algebraic expression.
Okay, all right. So let me, you're not giving me a chance to process. You're not giving me a chance to assimilate. Right,
so you see, it would have been nice if I sent it to you, though.
Yeah, I see your points. You do have a point.
Yeah.
All right. So you have one of your objectives that will be assessed, but you don't have an activity that will cover that objective. That's what you're saying?
No, I'm saying that with my objectives, right? What I did, I broke it down into different, we're using the concept. The concept map, I broke it down into there'll be different activities that will be taking place that will achieve each objective.
Okay.
For example, the last one will be an assessment. You see, connect what was learned in the lesson by completing an activity.
But your last objective will be an assessment, as in your.
Yes.
But the point I'm trying to make here is that all your objectives should be done in your development. There should be activity, not an assessment activity, but a development.
So you're saying that I should just, okay, I understand what you're saying now.
Uh-huh.
Right, I understand. So what I will do, I'll just switch it up and I will leave, because I will just let the, so can't I, so, okay, never mind. I don't have to do, I have to change it.
Okay, because the truth is, Carlene, is that you can't assess.
Zana.
Oh, because I'm not seeing you, Zana. The truth is, Zana,
oh,
you can't assess.
I have some stuff in my, yes.
I know you keep hiding from us to eat your mango, that's fine. Okay, Zana, what I'm saying is this, you cannot assess something that you didn't teach. So all your objective, for all the objectives.
No, it's not, miss, it's not something that I didn't teach her. What happened is that I have already taught the concept, but what they will do in the effective, because as effective, is that I'm giving them, they're going to now do it themselves. I taught them the process of doing it already. They have learned how to read the expressions, write the expressions. So what they will do now for themselves is to write their own individual example.
Okay, I see. That's fine.
But I restricted it though. I just told them, okay, I'm giving you one letter to work with, two numbers, and two operations, a choice of two operations where they now formulate. So they have to write it, translate it, and we're going to discuss it.
Okay, all right, no problem. Sounds okay.
Yeah. But the rest follows. But I put some time in on it to see, but then I will revisit the timing to see if it will be too long. Because I calculated the time to 15 minutes.
It sounds like you have a lot though, Zana.
Yes, but especially the activities, I will go back to see if I should cut down on one or two of them.
Yes, so go back and kind of check a little bit, all right?
No problem, thanks.
All right, who wants to go next? No. All right, so anybody else before we go? All right, I guess I'll see you guys on Thursday. Good luck. Planning and teaching. It will be my turn to sit and watch.
Thank you.
Thank you.
Okay.
I also emailed my lesson plan for you.
Why? I don't know if I'll get a chance to look at it. I can't promise anything.
I did since last night, so I'm not sure.
I'm not sure because I have other things, like I have so many other things to do, so I don't know if I get a chance to look at it before Thursday. So that's the reason why I try to discuss it in the class, for us to have a basic understanding and for me to make any correction, and everybody can benefit from that correction, right? But I'm not sure if I'll be able to look at it, to be honest, because even your work that I was supposed to mark, I still haven't gotten around to marking it. So that break that you get, huh? Why? Why?
Dominica, Miss Kevin.
I'll be fine because I have that week. I just take that week to do it. That's fine. I can mark your reading assignment in one. Each of us set up assignment in one day. Then mark, read and mark.
Mrs. Kelvin.
Yes,
Hello.
Yes, ma'am.
The assignment, one was the assignment 2. When is this due?
All right, so let's talk about this again. So I'm saying that because of you have 4 pieces of coursework, right, for this course.
Okay.
And this course was done basically in 3 weeks because I missed 1 week, right? Yeah. I couldn't figure out how to kind of give you the assignments or the due date for the assignments. So I decided that you have until next week, Friday. So the course will end this Friday, but you have until next Friday to submit all the assignments. So I'm not going to give you a due date for each piece, but just know that by Friday, I should receive all your assignments.
Okay, thank you.
Guys, if whenever you finish any piece, please send it out as soon as you're finished. Don't wait until Friday to send everything. It will be good for me to at least start browsing through and marking. But
okay.
Yes.
But, yeah. Okay.
But Friday at 7 is the deadline for all assignments. Please don't send your assignments after 7 o'clock, please. All right. Friday at 7 is a deadline. Okay.
Okay. Thank you.
Yeah. Excuse me.
Yes.
Which email address do you want us to send it to?
Gmail,
okay.
AVLLOY@gmail.com. Avalloy McCarthy 6@gmail.com. So it's the same Yahoo address, except that it is for it's not Yahoo but Gmail.
Okay.
It's the same. I don't want you to send it to my Yahoo because my Yahoo have a whole lot of other things that I can't start with it. All right. All right, so I'll see you on Thursday. Come prepared, please surprise me pleasantly, of course. And be creative and innovative. I'm looking to learn something from you also, okay?
Okay, good night.
All right, good night.
I'm learning something.
I'm looking to learn. We're all teachers. I'm looking to learn from